The United Nations just launched a planetary defense exercise targeting 3I Atlas. New images show a tail stretching 5 million kilometers, and Professor Avi Loeb just identified what he's calling the 12th anomaly.
The new images of 3I Atlas have pushed the situation into a true emergency, and the United Nations has now started a planetary defense mission that has never been used for an interstellar object. The latest observations reveal a tail nearly 5 million kilometers long and an anti-tail rising toward the Sun, creating a scene that challenges everything we expect from a natural comet. These structures appear stable and bright, and their size suggests a force far stronger than normal ice activity. With the UN stepping in, the question becomes even larger. If this is only the beginning, what will the next measurements reveal? The launch of the United Nations Planetary Defense Exercise marks a turning point because it shows that 3I Atlas has become more than an interesting object in the sky. The International Asteroid Warning Network announced a full observation campaign that will run from late November 2025 to January 2026. And this schedule is normally reserved for threats that must be tracked with great care. It is the first time they have selected an interstellar visitor for such a mission, and this unusual choice immediately raised questions about what they expect to find. The network explained that comets create difficulties during measurements because their glowing halos can shift the apparent position of the nucleus, which makes orbital calculations unreliable if the data is not collected continuously. This statement sounds reasonable, yet it does not explain why they needed a full-scale defense exercise. The official explanation is that the campaign is a valuable chance to practice with real data from a fast-moving visitor. But many observers noticed that the tone used by the agencies sounded cautious. When the Minor Planet Center released its report, several lines suggested that they wanted as many telescopes as possible to watch every change in brightness and direction. And this level of attention is not common for a normal comet. NASA repeated that Atlas is not a danger to Earth, but their wording focused on reassurance rather than detail. The European Space Agency added that this exercise would strengthen cooperation between observatories, which also sounded more diplomatic than scientific. These careful statements created a sense that something remains unexplained. Another reason the decision attracted attention is the history of the network itself. Since 2017, they have only organized 8 official exercises, and each one involved asteroids that passed close to Earth or had a small probability of impact. Atlas does not fit into that category because its closest distance is far beyond the range of genuine danger. Even so, the network acted as if they were preparing for a real-time test, which suggests that they want to understand the object even if they believe the public should remain calm. Several astronomers noted that the rapid motion of Atlas makes it harder to model, and this factor alone could justify extra monitoring. But the timing of the decision still feels unusual. The most interesting part of the announcement is the way the agencies avoided mentioning the strange behavior that private researchers and independent astronomers have reported for months. Instead of addressing the unexplained patterns in the tail and anti-tail, they focused on general statements about data quality. This unwillingness to acknowledge the unusual activity made many people wonder if the campaign is not only a training event, but a way to gather high-resolution data without causing alarm. Since interstellar objects cannot be predicted using long-term models, the agencies might be concerned that Atlas could behave in ways that challenge standard theories. As the exercise begins, the real question is why they waited until now to activate it. If they believe nothing is unusual, then why commit so many resources to something that should be harmless? This is where the next part of the story becomes even more important, because the new images captured by independent astronomers show details that the agencies have not discussed. What exactly did those images reveal that changed the tone of the entire investigation? The new images taken by independent astronomers became the center of attention because they revealed details that official agencies did not discuss, and these pictures quickly raised doubts about the quiet tone used by NASA and the European Space Agency. The most striking image came from Mitsunori Samura, who used a half-meter telescope to capture a tail almost 5 million kilometers long and an anti-tail stretching toward the Sun. The length alone would be impressive, yet the clarity and stability of the structure made it even more unusual. The tail did not show the widespread shape that many comets display, and instead it formed a narrow line that held its shape over a vast distance. Samura's picture was soon compared with additional images from Peter Carson Lilley and another observer named Walter, and all of them showed the same pattern. These images drew attention partly because they looked sharper than the ones released by NASA, and viewers wondered why amateur astronomers had clearer pictures than space agencies with far more advanced equipment. While the agencies said their instruments needed longer exposure times, the public noted that the independent images were consistent and displayed structural features that could not be ignored. The most interesting part is the way the anti-tail appeared as a bright, narrow column that reached more than 1 million kilometers in length, and it pointed directly toward the Sun in a way that does not match the expected behavior of dust under solar radiation. Instead of bending away, the column stayed straight as if it were held by an unknown force. This consistency across different observers suggested that the structure was not an artifact of equipment or processing. It hinted at a pattern inside 3I Atlas that allowed the jets to form a stable geometry. And this stability raised questions about whether the object was reacting to sunlight in a simple way or operating under more complex conditions. Normally, a comet losing material at high speed would show messy trails that change shape with solar wind pressure, but these images revealed lines that remained clean and sharp even as the object moved through space. Some viewers suggested that this look resembled a system with a controlled flow, and although this idea is only speculation, the comparison between natural comets and Atlas made the contrast difficult to ignore. The brightness of the coma in the images also captured interest because it stayed uniform despite the object's rapid motion. A normal coma often shows uneven patches where ice turns to gas, yet Atlas displayed a smooth glow with no visible breaks. This detail suggested that the source of the material might come from deeper layers rather than random surface pockets, and such a pattern would require an internal process that has not been fully explained. Even astronomers who view the object as natural admitted that the images reveal something highly unusual because the observed structures behave like organized streams instead of scattered dust. As the pictures spread online, the debate intensified because they contradicted the cautious tone of the agencies that had downplayed these details. This gap between official statements and independent observations became a key reason why the public began looking for deeper answers. If the object continues to show such precise shapes, then what will the next measurements reveal about the true nature of 3I Atlas? The 12th anomaly, revealed by Professor Avi Loeb, became one of the most puzzling clues because it focused on the rotation of 3I Atlas and the behavior of its long jets. The topic is simple to understand yet difficult to explain, since the jets should show clear signs of motion if the object rotates every 16 hours. A rotating body releases material in a pattern that forms curves, and these curves stretch into spiral shapes when seen over long distances. The jets of Atlas extend for more than 1 million kilometers, and over such a distance they should appear twisted or blurred. The new images, however, show straight streams with sharp edges, and this contrast is hard to ignore. Researchers expected some distortion because sunlight heats different parts of the surface at different times, which usually creates uneven flows. The fact that the jets remain narrow and stable suggests that the rotation might not match earlier measurements. Loeb proposed that the object may have slowed down since the summer, yet this idea does not align with what is normally seen in comets. Outgassing often increases the spin of an object, and this increased motion produces stronger curves. A sudden slowdown would require a force acting against the rotation, and no simple natural process explains this change. The behavior seems out of order, especially when compared to the predictable patterns seen in other space objects. Another explanation is that the jets may not be constant, but instead fire in short bursts that occur at specific points on the surface. Loeb described a possible scenario in which deep valleys hold ice that only receives sunlight at certain angles, and these moments of direct light produce focused streams. This idea could explain why the jets stay straight, yet it also raises questions about the internal structure of Atlas. If the surface has features that allow such controlled flows, then the object might be more solid or more organized than the loose, fragile bodies usually found in interstellar space. A comet made from soft material would not normally support such steady channels for gas release. The entire situation becomes even more unusual when the length of the jets is considered. A stream of material that stretches for more than 1,000,000 kilometers must leave the surface with significant speed, and this speed should highlight any changes in motion. If the object rotates even slowly, the flow should bend slightly, yet the images reveal almost perfect lines. This appearance has led some viewers to compare the jets to controlled exhaust rather than a natural release of gas. The idea remains speculative, but the similarity between these patterns and engineered streams has pushed many people to look for deeper explanations. As astronomers continue to study the anomaly, the larger question grows more important because the rotation of Atlas influences every part of its behavior. If the object is not spinning the way scientists expect, then what does this mean for the rest of its activity? This question becomes even more critical when we consider the next strange feature, which appears in the way the anti-tail moves through the solar wind. Could the rotation puzzle be the first sign that Atlas is operating under conditions that do not match natural models? The strength of the material flowing from 3I Atlas became one of the most surprising discoveries because the anti-tail pushed directly through the solar wind, and this behavior shocked many astronomers. The solar wind moves at around 400 kilometers per second, and it normally bends dust and gas away from any comet. Yet Atlas showed a column of material that stayed firm even under that pressure. A structure that remains stable in such an environment must carry a large amount of mass. And this requirement led Professor Avi Loeb to calculate how much material the object has been losing. His estimation suggests that several billion tons of matter have escaped from the surface over the last 2 months, and this number raised even more questions. A natural comet can lose mass as ice turns into gas, but the amount usually depends on the surface area exposed to sunlight. Hubble measurements indicate that Atlas has a nucleus far too small to release the amount of material shown in the images through normal sublimation. If the surface does not have enough area, then the gas cannot be produced at the necessary rate, and the anti-tail should be much weaker. The current observations show the opposite, since the column of dust and gas holds its shape across distances that reach 1,000,000 kilometers. This contrast between expected behavior and observed behavior has led many researchers to reconsider what kind of process might be active inside the object. Loeb noted that a technological thruster could create the same level of acceleration with far less mass loss because a controlled exhaust can move faster than gas created by sublimation. This idea remains speculative, but the comparison highlights the challenge faced by scientists who are trying to explain the anti-tail using only natural processes. Since the solar wind is a continuous stream of charged particles, any natural plume of dust should bend backward or scatter, yet Atlas keeps producing a column that travels in the opposite direction. Such behavior suggests that the forces involved may not match what comets normally experience, and this inconsistency increases the mystery. Another possibility is that the material leaving the surface is denser than expected. And if the particles are heavier, they could resist the solar wind more effectively. However, this explanation creates new questions because spectroscopic data collected so far does not show signs of unusually heavy elements. Without clear evidence of such material, the theory remains incomplete. There is also the chance that the internal temperature of Atlas is higher than predicted, which would allow deeper layers to produce strong flows. But astronomers have not found thermal readings that confirm this idea. Every potential explanation eventually leads to another missing piece, and the situation becomes more complex as new images appear. The next step for researchers is to gather more detailed spectroscopic measurements because these readings can reveal the chemical properties of the material and help explain how the anti-tail maintains its power. If the data shows that the gas behaves like ordinary comet material, the puzzle will deepen even further. This brings us to the next important event in the story. Since the encounter with Jupiter may expose clues that cannot be seen from Earth. What exactly will the object reveal as it moves toward the region where Jupiter's gravity becomes dominant? The upcoming encounter between 3I Atlas and Jupiter has become one of the most anticipated events in the investigation because it may reveal behaviors that cannot be observed from Earth. Jupiter's gravity controls a wide region around the planet, and this region is known as the Hill radius. Inside this zone, any object that enters can remain in orbit around Jupiter instead of being pulled away by the Sun. The fact that Atlas is expected to pass directly into this boundary on March 16, 2026, has led many researchers to wonder whether the timing is simply a coincidence or part of a pattern that deserves closer attention. Professor Avi Loeb pointed out that the exact distance at which Atlas will cross the Hill radius makes the event even more important. If the object releases material or fragments while inside this region, the pieces could stay in Jupiter's orbit and avoid drifting back into deep space. This possibility raised questions about whether the object might contain smaller components that could behave differently once separated from the main body. Since Jupiter's gravity acts as a natural trap, the encounter provides a rare chance to detect unusual activity that would be difficult to identify at any other time. NASA plans to use the Juno spacecraft to listen for radio waves during the encounter, and the antenna will scan frequencies from 50 Hz to 40 MHz. These signals could reveal electrical activity, and they may also detect patterns that point to controlled processes within the object. The presence of such signals would not confirm anything unusual by itself, yet it would open the door for further investigation. The European Space Agency has also taken interest, and its JUICE mission has already made early observations of Atlas, even though the data will not arrive until early 2026 due to slow transmission speeds. The delay created even more curiosity, especially among viewers who have been following the object's unusual behavior for months. Some astronomers believe that the encounter could show whether Atlas responds to changes in gravitational pressure, and this response might expose clues about its internal structure. If the object changes direction or brightness while inside the Hill radius, the shift could be detected by ground-based observatories. Every possible outcome adds new layers to the mystery, and the encounter has already been described as one of the most important moments of the entire investigation. As Atlas continues toward Jupiter, the question grows more urgent. If the object truly behaves in a way that does not match natural models, then what will the next gaps in the data reveal about the information kept from the public? The lack of clear data from major space agencies has become one of the most unsettling parts of the 3I Atlas story because each delay or missing update creates more questions than answers. NASA and the European Space Agency have released only limited information, and most of their statements focus on reassurance instead of detail. The public expected high-resolution images or precise measurements, yet only a small number of official observations have been published. The gap becomes even more noticeable when independent astronomers continue to share detailed pictures that show structures the agencies have not addressed. This difference in transparency makes many viewers wonder whether the agencies are being cautious or deliberately withholding information. The JUICE mission added another layer to this mystery because it captured early observations of Atlas during its approach. But none of the data will arrive until early 2026 due to slow transmission speeds. Although this delay has a technical explanation, it still fuels speculation because the timing seems strange. By the time the data reaches Earth, the object will already have passed its closest point, making the information less useful for real-time analysis. This situation caused some researchers to compare the event to earlier cases, such as the long silence surrounding Oumuamua or the confusing signals once recorded by Voyager. In those moments, limited information created long periods of public uncertainty, and the same pattern now appears with Atlas. The missing details also affect how scientists interpret the object's behavior, because without consistent measurements, many predictions become harder to verify. Observers have noted that the brightness, rotation, and tail structure sometimes change between updates, and without official data, it becomes difficult to confirm whether these changes are natural or unusual. Some astronomers believe the agencies may be waiting for more evidence before making strong statements, yet others argue that the quiet approach only increases suspicion. Since Atlas moves quickly and displays features not seen in other comets, the lack of frequent updates makes the investigation feel incomplete. These gaps in information force people to rely more on independent observations, and this shift makes the contrast between official silence and amateur reports even sharper. The missing pieces give the story an unsettling tone, because they suggest that major agencies might be preparing for findings that challenge standard explanations. As more viewers ask why key data remains unavailable, the mystery grows deeper. If the silence continues, what might the next phase of Atlas reveal that the public has not yet been allowed to see? The closest approach of 3I Atlas on December 19, 2025, is considered one of the most important moments in the entire investigation because it gives astronomers their best chance to study the object directly. At a distance of around 270 million kilometers, Atlas will still be far from Earth. Yet its position will allow telescopes to collect clearer measurements than at any other point in its journey. Scientists plan to use this window to study its light spectrum, temperature patterns, and tail composition. And these measurements may finally show whether the object behaves like a natural comet or something far more unusual. Spectroscopy plays a central role because it reveals the chemical fingerprint of the material released from the surface, and this method shows whether the gas follows the same pattern as ordinary sublimation. If the readings show unexpected elements or unusual ratios, the entire understanding of the object may change. Astronomers also hope to measure heat coming from the nucleus because temperature gives clues about internal processes. A normal comet warms only through sunlight, but if Atlas shows additional heat, the discovery could indicate more complex activity inside its structure. These tests are simple to explain yet difficult to predict because Atlas has already broken several expectations. The brightness of the tail is another key point, because the glow reveals how much material is leaving the surface, and this flow affects the direction and speed of the object. If the tail changes shape during the closest approach, the shift might show how the internal structure responds to stronger sunlight. A natural comet often shows scattered patterns, yet Atlas has displayed narrow and stable lines for months, and this contrast makes the upcoming measurements even more important. Ground-based observatories will focus on these fine details because small changes could reveal new information that cannot be detected from other distances. For many researchers, the closest approach acts as a final test before the object continues deeper into the outer system. Once Atlas moves away, the opportunity to collect high-quality data may not return, and this urgency adds more weight to the event. Viewers following the story understand that this moment may determine whether the object fits within natural models or continues to challenge everything scientists expect from interstellar visitors. As the date approaches, a single question stays at the center of the mystery. If Atlas is not acting like a normal comet, then what will the upcoming measurements reveal about the true identity of the object? The story of 3I Atlas now leads us to the biggest question. Because every anomaly, every delayed update, and every unusual measurement suggests that something far more complex may be unfolding. The 5 million kilometer tail, the rotation mystery, the strange power of the anti-tail, and the silent gaps from major agencies all point toward an object that refuses to fit into any natural model. As we wait for new data, we face a choice between accepting the simple explanation or looking deeper into the unknown. So what do you think Atlas truly is? Share your thoughts, subscribe, and join the conversation.